Quick intro. By degree of isolation, we can single out component testing, integration testing, system end-to-end testing. Let's define first and then illustrate. Component testing is the functional testing of a logical component. Integration testing is the functional testing of the interaction between two or more integrated components. System end-to-end testing is the functional testing of a logically complete path consisting of two or more integrated components. Let's illustrate. Programmer Willie was asked to write code that would find the full names and emails of all users who spent more than 1,000 shopping at ShareLane. We are going to send those users an email with a gift certificate giving them a 5% discount on a single purchase. Those certificates will be able to be used through November the 17th. This feature is called the 5% discount. By the way, please note that we've deliberately chosen not to illustrate this section with existing ShareLane functionalities. We did that to give you a feeling about test planning for software that doesn't exist yet. Component testing. Let's single out 3 components to test. Component 1, generation of certificate codes and the generation of a data file. Component 2, generation of and sending emails. Component 3, usage of certificate codes. Let's plan our testing. Component 1, program certgenerator.py has this logic. Check DB for qualifying users. If qualifying users are found, generate certificate codes and insert them into special DB table. Generate data file with full names, emails, and certificate codes. Else, exit. Let's narrow down our testing right away. We are not even going to consider a situation where there are no qualifying users because we know for sure that we have plenty of them on production. So, after the run of certgenerator.py, we should be able to check 4 things: data in DB, data in file, format of certificate code, format of data file. When the code is ready for testing, we'll perform testing on main.sharelane.com. Main. This testing environment has its own DB, and if necessary, we can manually change some data in it. Test planning. 1. Log into the DB of main and reset the total amount spent by each existing user to 0. We need this step to prevent legacy, existing data from interfering with our testing. Brain positioning. Remember that when you change a global setting, for example, the system time, or do global DB manipulation on a shared test environment, you should always ask those who use the same environment if it's okay to make those changes. You don't want to mess up their work. The need for global modifications for the purpose of testing is one of the reasons why it's a very good idea for each tester to have his own test environment. With the low prices of hardware and all the free software, for example, Linux, Apache, Python, MySQL, this shouldn't be a financial burden for a company. 2. Create data for positive testing by creating new user accounts and making them big spenders, those who spend $1,000.01 or more. Let's create only 2 accounts. One account that spent $1,000.01, another account that spent $1,002. By the way, as a shortcut, instead of creating new user accounts, you can pick 2 legacy users and manually update the DB with the necessary amounts of $1,000.01 and $1,002 for those users. Brain positioning. You have to really know what you're doing when you hack into the DB. In other words, when you perform a manual modification to DB data, even if your SQL query achieves its goal, you can end up with a situation where the data integrity is seriously compromised. Data integrity can be defined as the correctness, completeness, wholeness, soundness, and compliance with the intention of the creators of the data. Definition taken from techweb.com. When you make a manual modification to DB data, you almost always affect data integrity. The question is, to what extent? In some situations, nothing will break, but in others, bugs will show up in the most unexpected places, and the programmer will have to spend hours to debug the problem, only to realize those were not real software bugs, but consequences of violated data integrity. So again, know what you are doing. 3. create data for negative testing. You need two accounts. One that spent $1,000, another that spent $998. Here again, we can also do testing by using two existing accounts and hacking into the DB to update the table with the spending history for those users. 4. Run certgenerator.py. Expected results about the data? In the DB, two certificate codes are generated, one for each big spender. In the file has two records, one for each big spender. For each big spender, first and last name, email, and the certificate code are the same in the file and in the DB. By the way, in our case, the certificate code is a combination of 10 alphanumeric characters, letters and numbers, in uppercase. By the way, in our case, the data file must have a comma delimited format. It's when data blocks are separated by a comma. Here is the layout. Here is an example of the file. Expected results regarding the format? Certificate code. It should have 10 alphanumeric uppercase characters. We can look in the file to check the format of these codes. File. Each block must have the expected info. Look at the file format. The first block must have the first and last name separated by a space. The second block must have the email address. The third block must have the certificate code. Please note that we don't check to see if the record has info about the qualifying users. Users who spent more than $1,000. We've already tested that. We simply check the format. Blocks must be separated by commas. Component 2. Let's test this component in isolation. We'll do that by creating the file manually. How do we create the file? Not a big deal. We can do it using a text editor like Notepad. Test planning. 1. Manually create a data file and insert one record with the following data: a random first and last name, a valid email so you can check whether the software has really sent the email with the correct content, a random certificate code. 2. Feed the file as input to certsender.py. This Python script constructs email messages parsing the data file, sends out the emails. After certsender.py runs, there are two expected results. Email was received, positive testing. Email message has the correct content, positive testing. Also, you can do negative testing. 1. Create several bad data files manipulating with absent and or corrupt data and or wrong format. For example, record has no email. 2. Feed those files to certsender.py one by one. Expected result: error message each time when bad file is used as input, negative testing. Component 3. Let's test this component in isolation. How can we do this? As you recall, a certificate code is a combination of 10 alphanumeric characters. The certificate code must be entered during checkout, and if that code is valid, the total amount should be reduced by 5%. At ShareLane, we offer free shipping on all orders, so the total amount is a price of all books in the shopping cart. We can ask a programmer to generate some certificate codes for us, find out how to hack into the DB to manually insert some random certificate codes, write a helper script to generate those certificates. Test planning. 1. Get 11 valid codes. Let's assume that we have these numbers. 2. Set today as October 21 or any date before November 17 and execute our test cases. By the way, how do we simulate October 21, November 17, or any other date? Depending on the software design, the date is usually taken as the server system time or as some value from the DB. Therefore, we just need to change the system time or value in the DB. Again, make sure that it's okay with others if you make a global change on a shared environment. Be sure the data integrity will not be seriously impacted if you change the date in the DB. Please open up File Component 3 Test Cases Set 1, 3. Before executing each test case, set the date as noted in comment column. Please open up File, Component 3 Test Cases Set 2. We checked components 1, 2, and 3 in isolation. In other words, we assumed that they are independent from each other. Now it's time to test integration between those components. Integration testing. There are 3 points of integration. Component 1 to Component 2. Data file generated by certgenerator.py is used by certsender.py. Component 2 to Component 3. Certificate code taken from email message constructed and delivered by certsender.py is used to get 5% discount. Component 1 to Component 3. Certificate code generated by certgenerator.py is used to get 5% discount. Test planning. Component 1 to Component 2. 1. Log into the DB of main and reset the total amount spent by each existing user to 0. 2. Create one big spender account, for example, $2,000 spent with legitimate email. 3. Run certgenerator.py. 4. Run certsender.py against the data file generated by certgenerator.py. 5. Check your email account. Expected result. Email was received. Email has correct content, positive testing. Component 2 to Component 3 and Component 1 to Component 3. 6. Use the certificate code from the email to get a 5% discount. Expected result. Discount is granted. Positive testing. System end-to-end testing. A system test is a scenario to test a feature from start to finish. Component 1 to Component 2 to Component N. In our case, the system test can be done by executing steps 1 to 6 inclusively, used for integration testing. We looked at the system test last, but I recommend that you create one test case with a simple system test as the first test case of your test suite. Why? Because it will serve as an acceptance test for that particular feature. Lesson recap. 1. Component testing is the functional testing of a logical component. 2. Integration testing is the functional testing of the interaction between two or more integrated components. 3. System end-to-end testing is the functional testing of a logically complete path consisting of two or more integrated components. 4. You have to really know what you're doing when you hack into the DB or change some global setting. For example, server time. 5. Comma-delimited format is popular format for data files. Blocks of data are separated by commas.